Hi everyone, this is Zulekha from Edureka. I'm sure you all have come across Jenkins at some point, and in today's session we're going to discuss about the Jenkins pipeline, which is one of the major reasons behind the popularity of Jenkins. Alright, so let's get started with today's session. So today I'm going to cover the following topics. First, we're going to see why continuous delivery is so important and why so many companies are investing in continuous delivery. Next, we'll look at what exactly continuous delivery is. After that, we'll discuss a few features that existed before the Jenkins pipeline, and then we'll move on to what exactly a Jenkins pipeline is. Once we're done with that, we'll discuss a few pipeline concepts. So guys, after you've understood these 5 modules, I'm going to introduce 3 interesting demos in today's session. Now the first demo will show you how to create a Jenkins pipeline. In the second demo, you'll see how to create a declarative pipeline, and in the third demo, you'll see how to run a scripted pipeline. Guys, I hope the agenda is clear. So now let's look at our first topic, which is why do we need continuous delivery. So I'm going to explain this with the help of a small scenario. Here you can see that there is a group of developers who are committing their code into the code repository. Now this repository will compile and execute the code and then send it to the quality assurance or the QA team. Now this team will manually perform tests like unit tests and integration tests to check if there are any logical errors in the code. And once they're done fixing the errors, they'll directly deploy the application to production. But this has resulted in a failure. Now, why did the application fail? Let's look at a few reasons as to why this happened. Now, the first reason is that the environment in which the application was tested is different from the production environment. Now, if the two environments are different, they're going to support different libraries and packages. So that's why the code was compatible on the testing environment and not on the production environment. Alright. Now the next reason is that the production server is not capable enough of handling the end user load, because of which the server crashes. And lastly, the application is not accessible to the users. So guys, let's make the session more interactive. If you have any doubts or any questions, please comment them in the chat box. Alright, so Victor has a doubt. Okay, he's saying that he hasn't understood the end user load. Alright Victor, I'll explain this to you in simple words. So basically every production server has a threshold beyond which it will not be able to process any more user requests. Now if the production server is being flooded with too many user requests and it is not capable enough to process these many requests, then the server will end up crashing. Now that's why the application failed here. Alright Victor, so if you've understood, please give me a confirmation and don't hesitate if you want me to explain this again, I'll do it. Alright, thank you Victor. Now let's look at how all these problems are solved using the continuous delivery pipeline. Now in this case, you can see that the developers are directly committing their code into the continuous delivery pipeline. Now this pipeline has a few modules. The first is the commit module. Now this is where the code or any changes that you make to your code are committed and stored in a version control system. Now what is a version control system? Now it basically helps you track all the changes that you make to your code over a period of time. Now why is a version control system important? Now let me explain this with a small example. Let's say that there is a developer who's built an application and he wants to update the version of the application from version 1 to version 2. Now in order to do that, he's going to make a few code changes and then commit the code into the version control system. So now that he started using the application under version 2, he's facing a lot of issues. So he wants to shift back to version 1. Now he can easily do this because the version control system has tracked and saved all of the code changes that he's made. So that's why a version control system is important. Okay. Now let's look at the build module. Here you implement continuous integration using tools like Jenkins. So what is continuous integration? Now every time a commit is made to the version control system, that commit should be continuously pulled, built and tested using automation tools. So instead of manually performing the unit tests and integration tests, you can now automate them using tools such as Selenium and TestNG. So guys, note that automation is key here. So as long as you automate all of the processes, the delivery is going to be quicker and it's going to be less prone to errors. Alright. So now let's move on to the test environment. Now this is the most important part of a continuous delivery pipeline because it will make sure that the software is always in a production ready state. That is, the software has to always be in such a state that it's ready to release. Okay. Now let's see how the testing environment makes sure that the software is always in a production ready state. Now in order to do this, various tests are carried out, such as the user acceptance test and the load testing. Now what is load testing? Now this is performed to check the behavior of the application under a certain expected load. Now in the previous example, we saw that the application failed because the production server was unable to process too many user requests. Now in this case, by implementing continuous delivery, that failure is not going to occur because we are performing load testing, wherein we check how much of user load the application is capable of processing. Alright, now let's look at user acceptance testing. Now this test is performed to check if the users can access the application without any problem. Now even if the users are facing a problem, then a feedback will be immediately sent to the developers who will make the required changes and commit them into the version control system. Alright, so guys, this is how a continuous delivery pipeline works. It will make sure that the software is always in a production ready state so that the software delivery cycle is more quicker and more effective. Alright, now that we've seen how this continuous delivery pipeline solves all of these issues, let's look at a few advantages of continuous delivery. Now the first advantage is that it automates software releases. Now continuous delivery makes sure that it uses automation tools at each and every step of the software development cycle. Whether it's building, testing or deploying, all of these steps have to be automated. Now because of doing this, the software is released at a faster rate and it is less prone to any human errors. Now the next advantage is that it increases the developer productivity. Now because continuous delivery is fully automated, the developers can finally focus their attention on building new features. And lastly, it locates and addresses bugs quicker. Now finding bugs becomes easier because you can track down the commit which caused the bug and then you can fix the bug using automation tools. I hope all of you are clear with the advantages. Now let's move on to what is continuous delivery. So I'm sure all of you have an idea of what continuous delivery is. So far we saw that continuous delivery is just a practice which makes sure that the software is always in a production ready state. Now how do you make sure that the software is always ready to release? Now every time a code is committed to the version control system, that code has to be continuously pulled, built and tested using automation tools. Now by automating every step, you're going to make sure that the delivery is more rapid and effective. Now guys, let's see how continuous delivery solved the problems at HP. Okay, so HP's LaserJet firmware division was responsible for running all of their scanners and their printers. But in 2008, they were facing a serious problem wherein the product delivery cycle was very slow. So they were unable to release any new features or any new products, and all of their customers were disappointed because they weren't seeing any improvements in their products. And they were lagging with respect to all of their competitors. So now they decided to fix the problem by hiring more people. They tried to outsource, they even tried to spend more money. But despite all of their efforts, none of these things worked. So what they did was, they came up with a new plan. And the target of this new plan was to improve the developer productivity by a factor of 10. Now in order to achieve this, they came up with 3 high-level goals. Now the first goal was to find a single platform that would support the entire software development workflow. The second goal was to make sure to release improved quality software. And the third was to ensure faster releases. So how did they achieve all of this? Now they implemented a continuous delivery pipeline with 2 important features. So first they started practicing continuous integration very religiously. So they made sure that every time a commit was made to the version control system, that commit was continuously pulled, built, tested, and then pushed to a non-production environment. And all of these steps were automated to make sure that the delivery is more faster. Now let's look at the end results of these practices. So firstly, the overall development cost reduced by approximately 40%. The programs under development increased by approximately 140%. And the development cost per program went down by approximately 78%. Now guys, this is a huge difference in their delivery cycle. So how did they make sure this happened? They implemented continuous delivery and they practiced continuous integration, and they made sure they use automation at every step. So by following these few key practices, the delivery cycle was much better and much faster. Now, before jumping into how Jenkins pipeline uses continuous delivery, let's look at a few features that existed before the Jenkins pipeline. Now, before the Jenkins pipeline was introduced, there were several other features such as the Jenkins build flow, the Jenkins build pipeline plugin, and the Jenkins workflow. Now, what were the key features of these plugins? They basically represented multiple jobs as one whole workflow, and they run this workflow on a pipeline. And what was the function of these pipelines? These pipelines were just a collection of jobs which triggered each other in a specified sequence. Now let me explain the build plugin pipeline to you with an example. So over here you can see that I've created a simple application which consists of 3 jobs. Now the first job is responsible for building the application, job number 2 will test the application, and job number 3 will deploy it. Now after I've created these 3 jobs, I'm going to chain them together and then run them using the build pipeline plugin. Now on the screen you can see the output wherein job 1, job 2, job 3 are chained together and then run using the build pipeline. Now this approach is effective when you're building applications which have small number of jobs. So let's say your application has 5 to 10 jobs. You can easily build these 10 jobs, then assign processes to each job, and then chain these jobs together, and after that run them using the build pipeline. But what happens when there are complex pipelines with hundreds of jobs? Now imagine creating 100 jobs individually, then assigning processes to each of these 100 jobs, then chaining them together and then running them on the pipeline. Now this is very complex, guys. It takes up a lot of resources, it takes up a lot of time, and it's also very tedious to do. So for these reasons, the Jenkins pipeline project was introduced. So now let's look at what is a Jenkins pipeline. So it is basically a single platform that will run the entire pipeline as code. Now let's say that your pipeline has 10 jobs. So instead of manually creating these 10 jobs and then chaining them together and then assigning processes, you can just code these jobs and then run them on the pipeline. And remember guys that this code is stored in a text file known as a Jenkins file. And this Jenkins file can be checked into a version control system so that the developers can easily access and edit this file at any point of time because it's locally available to them. Now let's move on to a few key features of the Jenkins pipeline. Now the first feature is the pipeline as code concept. So basically instead of creating 100 jobs, you're just going to code them and then run them on the pipeline. The second feature is that the code can be checked into a version control system. Now this is advantageous because the developers can easily access and edit the code at any point of time. And not to forget that the version control system will always keep a track of all the changes that you make to your code. Another feature is that it incorporates user input. Now because of this, the users can easily interact with the pipeline. And it also lets you restart from saved checkpoints. So instead of redoing your entire job, you can save it and then come back to that checkpoint and start your job again. Another important feature is that it runs the jobs in parallel. So let's say you have 10 jobs. So instead of running these 10 jobs individually, you can divide them into 2 groups and then run them parallelly. Now this will save up a lot of time and a lot of resources as well. The next feature is that it integrates with other plugins such as Git, Docker, and etc. And also it supports complex pipelines by allowing you to use conditional loops such as the for loop and the when loop. Alright guys. So guys, please ask questions. If you have any doubts, please comment them. Okay, so Samiksha has a doubt and she's saying that how does it incorporate user input? Okay Samiksha, now let's say that you've created a pipeline which runs 5 jobs. And after executing 2 jobs, you want the user's input to check if the user wants to continue executing the next jobs. So for these reasons, you can make use of the user input feature. Alright, now Samiksha, please confirm with me if you understood. Alright, thank you. Now guys, don't worry because I'm going to implement most of these key features in the demo so that you practically understand how this works. Now let's look at what is a Jenkins file. Now the entire code of the pipeline is going to be stored in a text file, and that text file is known as a Jenkins file. Now remember that this Jenkins file can be stored in a source control management or it can be stored in a version control system. Alright, and the advantages of doing this is that It will let the developers access, edit, and check the code at any point of time. Another key feature of the Jenkins file is that it is written using the Groovy domain-specific language. And this can be done in two ways. So let's look at the two ways of writing the Jenkins file. So first is the declarative pipeline, which is a very recent feature when compared to the scripted pipeline. And the scripted pipeline uses a stricter Groovy syntax when compared to the declarative pipeline. Now, one key difference between the two is that the code for a declarative pipeline is written locally in a file which can later be checked into a source control management. Whereas for a scripted pipeline, the code is directly written on the Jenkins user interface. Okay guys, so here we need to understand that there are two ways of writing the Jenkins file. The first way is to write the code in a file and then store this file in your source control management system. And the second way is to directly type out this file on the Jenkins user interface. Alright, I hope you guys understood the two ways of writing a Jenkins file. Now another key difference between these two is that the declarative pipeline code is defined within a pipeline block and the scripted pipeline code is defined within a node block. Now these two blocks will be discussed in the next slide. So let's move on to the pipeline concepts. Now these concepts are basic fundamentals of the Groovy code. Now if you want to code the pipeline, you need to have a basic understanding of the Groovy code. So let's look at a few concepts that the pipeline uses. Now the first is the pipeline block. Now within this block, you're going to define your entire declarative pipeline code. And similarly, within the node block, you'll define your entire scripted pipeline code. I hope I've made this clear. Now let's look at the agent directive. Now what is an agent? Now agent is an executor which will run the entire pipeline or a specific stage depending on where you define the agent. Guys, I'm going to discuss stages in the next slide. Now agent has a few parameters. The first is the any parameter. So whenever you run agent with any parameter, it means that the code will run on any available agent. So Jenkins is basically going to look for an executor that is available and it's going to assign this executor to run the entire pipeline or a stage. Now the next parameter is a none parameter. Now guys, remember that every time you define agent with none parameter, it has to be mentioned at the root of the pipeline. Okay, you cannot define the none parameter within stages. You have to define it at the root of the pipeline. And what does this none parameter mean? It means that every stage within a pipeline will have to define its own stage specific agent. Alright. So now let's move on to the next parameter, which is label. Now label is basically a name that you give to your agent, and the labeled agent will run the entire pipeline or a stage. After that is the Docker agent. Now in the example below, you can see that within the pipeline block, I've defined a Docker agent which runs a simple Docker command. So it basically pulls an Ubuntu image from Docker Hub. Guys, don't worry about this command. This is a Docker command. Now take note that I've defined this Docker agent at the root of the pipeline. This means that the entire code within this pipeline will run on the Docker agent. Okay. So now let's move on to steps and stages. Now the entire workflow that's written within a pipeline is executed within a stage. So you can see that within each stage, I've defined a specific task. So stage 1 is going to build, stage 2 is going to test, and so on. Okay. Now steps are always defined within a stage and they are carried out in a sequence to execute a stage. Now in the example below, you can see that within the build stage, I've defined a step which runs a simple echo command. Okay. Alright, so Christopher has a doubt here and he's saying that how will the agent run in the stages example? Alright, Christopher. So let me put this down into simple words. So you can see that immediately after the pipeline block, I've defined an agent with any parameter. Now this means that all of the stages within the pipeline block will get executed on any available agent unless any of those stages will define a stage specific agent. So let's say that the test stage defined a Docker agent. It means that only the test stage will run on the Docker agent, whereas all of the other stages will run on any available agent. Now, because in this example, I've defined agent with any parameter at the root of the pipeline, that means that all of the stages will run on any available agent. I hope that's clear. Guys, please don't be hesitant if you haven't understood it properly. I'll explain it again. So please give me a confirmation, Christopher. Alright, thank you, Christopher. Guys, so now let's start off with a demo. Now in this demo, we're going to learn how to create a Jenkins pipeline. So we're going to see how to create a scripted pipeline and how to create a declarative pipeline. Now take a note that we're just going to learn how to create a scripted pipeline and a declarative pipeline. We're not going to actually run any code in this demo. That will be done in the next two demos. So let's get started with our first demo. Alright guys, now after logging into Jenkins, go to the left hand side and within the dashboard, choose new item. Now enter a name for your project. Then click on pipeline project and then click on OK to proceed. Now this will lead you to the configuration page of your pipeline. Now scroll down to the pipeline option. Now here within the definition, you can see that there are two options. One is pipeline script and the other is pipeline script from source control management. Now, if you want a scripted pipeline, you're going to click on pipeline script and you're going to start typing your code here itself. All right. Within the script block, you're going to start typing your code. But if you want a declarative pipeline, then you're going to choose pipeline script from source control management. And then you're going to enter the source control management that you're using. In my case, I'm going to choose Git. And after that, you'll have to enter the repository URL. So after entering your repository URL, just scroll down to the script path. Now within the script path is the name of the file which contains your entire source code. Now whatever you want to execute on the declarative pipeline will be stored in this file. Now in this case, a file known as Jenkinsfile is going to be accessed from my GitHub account. So let's go to my GitHub account. Here you can see that I have a file known as Jenkinsfile. And this file contains the entire source code. Now let's click on apply and save. So now you've successfully created a declarative pipeline and a scripted pipeline. Now let me just briefly run you through what we did here. So first you log into Jenkins and then you select new item from the dashboard. After that, you'll enter the name of your project and then you'll click on pipeline project and then click on OK. Once you're done with that, you're going to choose if you want a scripted pipeline or a declarative pipeline. For a scripted pipeline, you're going to choose pipeline script and then you're going to start typing your code on the instance itself. After that, if you want a declarative pipeline, you can choose pipeline script from source control management, then enter your source control management system and then enter the repository URL. After that, within the script path is the name of the file that is going to be accessed from your Git account. Then finally click on apply and save and you have successfully created your pipeline. Guys, I hope all of you understood how to create a Jenkins pipeline. So now let's move on to the declarative pipeline. Now before jumping into the demo, let me explain the code that we're going to execute. Now this is a simple declarative pipeline example. Now within the pipeline block, you can see that I've defined 4 stages. Now at the root of the pipeline, I've defined agent with any parameter. Now this means that all of the stages are going to run on any available agent unless any of the stages have defined a stage specific agent. Now in this case, you can see that stage number 1, 2 and 3 have not defined any stage specific agent, but within stage number 4, there is an integration test stage which has defined a Docker agent. So only this integration test stage is going to run on the Docker agent, whereas all of the other stages will run on any available agent. Alright, I hope this is clear, guys. So please give me a confirmation if all of you understood this. Alright, thank you guys. Now let's look at the stages. Now in stage number 1, I've defined a step which runs a simple echo command. That is, it will basically display whatever is mentioned in the quotation marks. After that, within stage number 2, I've defined an input directive which will pause the pipeline for user input. So basically when the input directive is executed, the pipeline gets paused and it waits for the user input. Now after it gets the user input, it will continue execution. Now in this case, the user is asked, do you want to proceed? Now the user will either click on proceed or abort. So if the user clicks on proceed, then the execution is going to continue to stage number 3. Otherwise, the execution is going to stop. Alright. Now let's look at stage number 3. Now within stage number 3, I've defined a when directive with a not tag. Now whenever the conditions within this when directive are met, the next step, which is echo hello, will get executed. Now the not tag is executed whenever the nested conditions within the not loop are false. So whenever branch master holds false, the next step, which is echo hello, will get executed. Alright. Now guys, let's move on to stage number 4. Now stage number 4 defines a parallel directive which runs unit test stage and integration test stage in parallel. So both of these stages are going to run parallelly. Now within the integration test stage is a Docker agent, which is a stage specific agent, and it runs two commands, that is reuse node and a simple Docker command. Now the reuse node is basically a boolean which is set to false by default. Now if reuse node was set to true, it means that the Docker container is going to run on the agent specified at the root of the pipeline. And in this case, at the root of the pipeline, we have defined agent with any parameter. That means if reuse node was set to true, then the Docker container would run on any available agent. Alright. Now because reuse node is set to false, this Docker container will run on the Docker agent itself. Alright. Now the next command is a simple Docker command wherein Docker will pull an Ubuntu image from Docker Hub. Okay. After that, a step is executed which runs a simple echo command. I hope the code is clear to everyone. Now let me just give you a brief overview of what every stage is going to do. Alright. So stage number 1 will run an echo command which will display a simple message. Now stage number 2 will run an input directive because of which the pipeline is paused and the pipeline waits for the user input. After that, stage number 3 defines a when directive with a not tag. Now whenever the conditions within the when loop are met, the next step will get executed. Now stage number 4 will run unit test and integration test in parallel, and unit test will run an echo command. Now the integration test stage is run on a stage specific Docker agent. So this agent will basically pull an Ubuntu image from Docker Hub and it will run the reuse node command. Alright guys, so I've defined a project called Declarative Pipeline, and let's look at the configuration of this project. Now on scrolling down to the pipeline section, you can see that within the definition, I've chosen pipeline script from source control management. Alright, because this is a declarative pipeline. Now I've chosen Git as my source control management, then I've entered the repository URL as well. And then within the script path is the name of the file which contains my entire source code. Now let's click on apply and save, and let's start executing this pipeline. Now click on build now and the execution is going to start. Now guys, the first block is a simple checkout from my source control management. Now stage 1 has completed execution. Let's look at the logs of stage number 1. Now here it's printing a simple message which says, hi, this is Edureka from Edureka. Alright. Now let's look at stage number 2. Now here you can see that the pipeline is paused and it's waiting for my input. So it's asking, do you want to proceed? So if I click on proceed, the stage 3 will get executed and so on. But if I click on abort, the execution is going to stop. So let's click on proceed. So stage 3 is now getting executed. So now let's look at the logs of stage number 3. It's printing a hello message. Now this message is printed whenever the conditions within the when loop are met. So basically the branch master holds false. That's why this hello message was printed. Guys, branch master is a simple git command. Alright. Now let's look at stage number 4. Now stage number 4 runs unit test and integration test in parallel. So now let's look at unit test. Now unit test is displaying a simple message which says running the unit test. Alright. Now let's look at the integration test. Now within the integration test, a general checkout is done from my source control management. After that, the Docker agent will pull an Ubuntu image from the Docker Hub. And then a simple message gets printed which says running the integration test. Alright. So guys, with this we complete the execution of the declarative pipeline. Now let me just give you a brief overview of what we did here. So after we started building the pipeline, it was paused on stage number 2 where it asked for the user input. So after clicking on proceed, the execution continues and all the stages get executed. Alright guys, now let's move on to the scripted pipeline demo. So before jumping into the demo, so let me explain the code that we are going to execute in the scripted pipeline. Now here you can see that I've defined the code within a node block. Now because this is a scripted pipeline, it has to be defined within a node block. Now within the node block, I've defined a for loop which creates two stages, stage number 0 and stage number 1, and both of these stages will print a hello world message. After that, there's an if loop which is executed whenever I is equal to 0. This means that only stage number 1 will run the following two commands, which is git command and echo command. Now the git command will basically clone the repository that I've mentioned within the URL. Alright. Now after the git command is executed, the echo command gets executed. Now the echo command will simply display the message. After that is the else block. Now this block runs whenever I is not equal to 0, which means that stage number 1 is going to execute the following two commands. Now the first command is the build command. Now within the quotations, I've defined declarative pipeline. Now this is the pipeline that we created in our second demo. So what do you mean by build declarative pipeline? It means that it's going to run this declarative pipeline within the scripted pipeline. Alright. So build is just used to trigger another job. Okay. Next is the echo command, which will display a message. Okay guys, I hope all of you understood the code. Now let's move on to the demo. Alright guys, so I've created a scripted pipeline. Let me show you the configuration of this pipeline. Now within the pipeline definition, you can see that I've chosen pipeline script. Now this is because we're developing a scripted pipeline. Okay. Also note that I've typed out the entire code on the user interface itself. Okay. Now let's click on apply and save, and let's start building this pipeline. So click on build now. Now guys, make sure that you've opened the declarative pipeline in another tab, because we're going to trigger the declarative pipeline through this scripted pipeline. Okay. So stage number 0 finish execution. Let's look at the logs. So it prints a simple hello world message. After that, it clones a git repository, and then it prints another message which says running on stage number 0. Now let's look at stage number 1. Now stage number 1 printed a simple hello world message. After that, it started building the declarative pipeline. Now this is the pipeline that we created in our second demo. Now let's see if that pipeline is executing. Now let's go to the declarative pipeline. Now here you can see that this pipeline is being paused for my input. So let's click on proceed. And once this completes execution, it's going to go back to the scripted pipeline and run the final echo command. Okay. So now let's go back to the scripted pipeline. And here you can see that stage number 1 finish execution. So it finished building the declarative pipeline, and after that it printed a message which says running on stage number 1. So guys, with this we finish our scripted pipeline demo as well. Now let me give you a brief overview of what we did here exactly. Now within stage number 0, you can see that we printed a simple hello world message, then we cloned a git repository, and then we run an echo command. After that, for stage number 1, we printed a hello world message, then we started building the declarative pipeline here. So once we start building the declarative pipeline, it starts executing it. Now here you can see that the declarative pipeline is paused for my input. So after clicking on proceed, it will complete the execution of the declarative pipeline. Now after that, the stage number 1 will complete execution and it will print a message. Okay. So with this, we finish our scripted pipeline demo. So guys, let me just summarize today's session. So first we looked at why continuous delivery is so important and the problems that occurred before continuous delivery pipeline and how the continuous delivery pipeline solved the issues. After that, we saw what exactly a continuous delivery pipeline is, and then we saw how HP solved all of its issues by implementing the continuous delivery pipeline. And then we moved on to what exactly a Jenkins pipeline is. We studied a few features of Jenkins pipeline, and then we spoke about the Jenkins file, where we compared the declarative pipeline and the scripted pipeline. After that, we discussed a few pipeline concepts, and then we introduced 3 demos. Now in the first demo, we saw how to create a declarative pipeline and a scripted pipeline. In the second demo, we saw how to run a declarative pipeline, and in the third demo, we saw how to run a scripted pipeline. So thank you guys. I hope all of you found this informative. Thank you guys for joining me today. Have a great day.